Yeah.
Whatever.
I like it. I like it. Okay. So I wanted to go ahead and start on time. So we may have some board members that end up joining us a little bit later on. Hi, Janie. Thank you for joining us. Actually, thank you everyone for joining us. I'm just giving sort of special attention to our board members. I know everyone's busy. I'm going to actually, because Phyllis is not really here to sort of, did she? Oh, okay. Phyllis?
Hello.
There she is. There's Phyllis.
There she is.
I am here.
Wonderful. All right, so I was just sort of going through the introduction and thanking everyone for their attendance. And so would you like to go ahead and sort of bring us in? Do we have?
Okay. Subcommittee meeting come to order. Welcome. I hope your day is going better than mine is. I had a dentist appointment this morning at 10 o'clock and set my alarm clock for 8:30, promptly turned it off instead of turned it to snooze. And at 9:45, my husband said, "Don't you have a dentist appointment?" I made it.
Well, there you go.
Even if you were in your pajamas.
No makeup. No makeup, no food, no much of anything, but I made it.
You know what's funny is I'm pretty sure that they appreciated the fact that you were on time over the whole no makeup thing.
Yes, I think they were impressed.
Did you have any updates that you would like to share with the group?
I don't think so. I somehow don't have my agenda right here, and I don't know why. I've made several copies of it through the last few days. So
You left him at the dentist.
Well, it's okay. We've actually moved to kind of our point of contact Q&A. So if we can, we'll start with Mike Borders. Let me just refresh your memory. Mike actually presented during our March meeting on liquid waste. He gave the update on preparing for the spring outage. So did any of you have any questions for Mike, or Mike, did you have any comments that you would like to make at this time?
No initial comments from me other than just to field questions relative to my presentation. We did see the draft recommendation, and I've got experts that I brought with me, and we did want to talk about that at the appropriate time. So,
okay. Are there any board members at this time that have any questions or comments for Mike?
Well, I'm not sure if this is really for Mike, but I got the Aiken Standard article, of course, about the cracks, and I was wondering if we could get any elaboration on that today.
are you talking about the SDU, the NCR condition we had on the SDU with where we have the gap between the ceiling and the walls?
That's the article we've been saying, yes.
yeah.
Yeah, so I'll speak to it briefly, and then Kent can chime in. I've got Kent Rosenberger on as well. So what we noticed on SDUs, I think it was 6 and 7, and it might have been 8 as well, is there's a construction joint at the top of the walls of the SDUs where there is a seal that's there where the ceiling sits on it, the concrete ceiling that's poured, and in some places that joint. We've had some degradation in that. It's a small gap. It is a non-functional issue related to the SDUs. The SDUs have already been conditionally released because it's not impactive to their form, fit, and function. And there is a plan to do, I'll call it more of a cosmetic repair to it. And Kent, you can correct me if I'm misstating what I'm remembering, but more of a cosmetic repair to it, and it does not impact its function. Kent?
Thank you.
All right, so there is no possibility of ingress of water or any other material?
No, this is disjoints on the side. It's, you know, it's like where the ceiling sits. So it's not a liquid pathway in. I will tell you, when we make grout, there is water that's part of just the process that then becomes part of the grout solidification for the SDUs, and any there is a system on the SDUs as well that they actually can return like water back to the saltstone processing room if needed. Hey, Kent, are you can I want to make sure your audio is working. I see you, but I haven't heard you yet.
Yeah, it's working.
Yeah. Do you have some additional comments to make beyond what I've said?
Well, the only thing I'd add again is that that area that had the foam and the bearing pad does not perform a structural function whatsoever on those units. Literally, the walls and the ceiling on those units are made to be able to, quote, float, so that they can expand and contract as necessary when we fill them up with grout. And so that while yes, we did see an air gap in there, but that was, we believe, just normal degradation of that foam. And again, we're doing an evaluation to determine what we want to do there, but really it's not impacting the form and function of the SDUs at all. It's just more or less a gap that was filled up by foam during construction.
So in other words, we're not dealing with the possibility of any radioactivity leakage.
No, no,
Okay.
we've got ventilation on those units. We have done precautionary surveys just to make sure that if the question came up, we found nothing. And we're continuing those surveys just as a precautionary measure, but we do not expect to see any issues there.
Another thing to add to the comment, that seals at the very top of the walls where the ceiling sits. We don't feel radioactive grout up to that level. Eventually, once the SDUs are filled operationally, we will put a clean cap in there in that space, but not radioactive grout. And of course, that'll eventually set up as well. So,
Thank you.
All right, what's the nature of the failure? Is it radiolysis or just failure of the material?
yeah, think of it like when you see this is a different analogy, but similar. Think of like when you see concrete poured and you see expansion joints that are flexible expansion joints in various structures. This is kind of like a joint where two concrete poured, the walls to the ceiling is done, and it's as Kent described, it's like a foam type material, and I'd call it just normal degradation of the material that's there. And once again, like Kent said, it's being evaluated, and they'll probably, I imagine when we're done, there'll be some kind of just cosmetic repair, but I don't think we've made a final decision on that. And Kent, you can correct me if I misspoke.
No, that's correct. That's correct.
Let me ask a question about the ventilation. How big are the pipes for the ventilation in these STUs?
I think Kent misspoke. I think what he meant was this air sampling in the area. Can you clarify that, Kent? This is John Clark. You said ventilation,
Yeah.
but I think you meant air sampling to ensure there's no radioactive materials, just as a precaution.
Well, we do have air sampling, but those units also have a passive ventilation vent that go to HEPA filters on the roof just to handle any changes in temperature, etc. I think those openings, I'd have to look at it specifically. I think there may be a foot and a half in diameter on the roof of the units.
And y'all have monitors on these ventilation units then, right?
No.
Yeah,
We do
so-
air sampling in the area, but they don't have installed radiation monitors on them.
Yeah, so
Why not?
So let's clarify, just to make sure we're clear, those are passive ventilation systems, like for the unit to just breathe due to ambient temperature fluctuation. It's not a forced ventilation system. It does.
Yeah. What I'm asking though is there any way we could get isotopes or something, radioactive material passing through these filters?
No,
We-
no,
we-
they're HEPA filters, and they are tested on a routine basis to make sure that nothing can get through.
So
Okay, thank
they're
you.
yeah, they're tested, and they do periodic surveys around those units, and it demonstrates that nothing is migrating out.
Okay.
Correct.
All right. Did we have any additional questions or comments from anyone in the room or online?
While you're
Okay.
thinking, I will give you just a brief update, because obviously part of it was the spring outage. So we're wrapping up our production this week to get into the spring outage. There are some scopes that have started some preliminary work to go into, but we start taking down steam to the facilities at the end of the weekend, and it's a site-wide steam outage. And of course, then our outage is even longer than the site steam outage. It's it's a good month and a half to 2 month outage that we'll be in for major upgrades. So.
Thank you for that information, Mike.
Is now a appropriate time to talk about the draft recommendations, since it's related to the waste tanks? Or
Well, I was going to go ahead and find out if anyone had any questions pertaining to the Legacy True Waste update,
okay,
and then we can move to the recommendations. Is that all right?
Sure.
Wonderful. If no one has any questions about that, then we can move right to the first the draft recommendation. Well, all righty then. So absolutely. Let's take a look at.
I'm sorry, you go ahead. You got
No, go ahead. I was just going to say, we're looking at preventing water damage and turf growth on in situ deactivated and decommissioned facilities using epoxy. So go ahead, Mike, if you were ready to go into it.
Yeah, so the one we have is titled Spraying Tank Interior and Radiation Monitoring. And
Yeah.
it talked about using epoxy material.
Oh, yeah.
And there was a and so there was a question. There was a question that was raised when I was talking just about the weld process on the tanks, and I don't know if that was the origin of this, or I can speak to the welds on the tank first, or if you just want to go right into why we believe this is not something that's needed. How would you like to just go into the recommendation?
We certainly can, if you'd like. This is now the time for discussion.
Yeah, so these tanks are fully welded. They are, not only is when we built them, the rolled steel that made up the walls was rolled by the vendor, and it was done with a heat treated process where they basically annealed the hot rolled steel so that to relieve the stresses. And so then it gets to when it got to the sites and we did the welding, those were full penetration welds at all locations. And those also got heat treated to relieve any of the stress around the weld field, and to where the weld is actually stronger than the steel itself. Back when they were constructed, they got x-rayed. We hydro tested the units. And then we've had a inspection and a chemical management program to prevent corrosion of the units themselves, so that they're carefully monitored. When you get into issues like related to when we empty the tank and whether anything additional is needed, like an epoxy, you get into issues related specifically to the PA and what it's engineered to do. And so I asked Kent Rosenberger, who's our probably subject matter expert on that, and I think Aaron Staub's on here for engineering, to basically be here to talk about that and why there's no coatings that is necessary. So Ken, I was gonna start with you.
Sure. So the in the closure so maybe I'll start real quick with why we don't see any corrosion in the tanks as they sit today, because we have a very rigorous corrosion an active corrosion control program that ensures that the pHs of the liquid stay well above, I think they're above 13 typically in the tank. And so That and as Mike said, the active monitoring of the tanks have not shown any degradation or corrosion of the tank liners to date. So if we go into the closure mode, the reason we haven't gone to anything similar to what was added there in the recommendation is that once the tanks get filled with grout and the annuli get filled with grout, in most of those cases, you have cementitious material on both sides of that carbon steel. Cementitious leachate for a long, long time is a pH of greater than 11. So when the tanks get filled with grout, not even, I'll say, almost better than what we deal with today, which is an active system that requires actions on our part to ensure that it maintains those conditions. After closure, it's actually a passive condition because any liquid that might get into the tanks and get through the cementitious material will be conditioned such that the pH is of a level that the tanks won't corrode. And so if you are interested, we have a pretty lengthy technical report that was done as part of our tank closure performance assessments. Those things are all publicly available. That goes into all the mechanisms that would happen with a tank in a post-closure situation. And Aaron can correct me if I'm wrong, but I think that we're well over probably 1,000 years for I'll say the thinnest wall tanks of the liners maintaining integrity, and several thousand years for the other tanks. And that again was looking at uncertainty, etc., in the assumptions in the closure condition. So compared to the, I'll say the, okay, so and I'd say in comparison to most epoxies and coatings, those things wouldn't be have a lifetime of anywhere close to that kind of life, especially considering the chemical environment, etc., of some of the leachates and some of the residual material. If it was on the lower parts of the tank, you'd also have there is still residual radioactive material left in the bottoms of the tanks, and that would also impact epoxy life. It really starts to embrittle that material, etc. And so that's just again those kinds of things. If you're we'd be happy to share those reports because they are publicly releasable and are public. They're approved for public release, and I believe they're probably all on the NRC's public website as part of as one of the PA reference documents. So if you wanted to dig into that it's certainly available for you guys to take a look at. So that's the first. That's, I'll say, number one. Are there any questions about that? And wait, maybe I have a question actually about the second sentence of extending to a level 2 feet above ground level. What was that referring to?
Okay. I have never seen a tank, seen a drawing of the tank. I passed by them when I first started. I've only, I've been in there about a year. But, my experience, I don't know. I keep wondering about the base of the tanks. And I was told that it was butt welded steel. I don't know how thick the steel is. And, it's just basic steel uncoated. And, today I know on pipelines and all, when they do welds, they x-ray everything. And I assume when these tanks were made, the bases were not x-rayed. And I know about welding a little bit. I know a little bit about a lot of stuff. I don't know a lot about any one thing, but I know that you can get flux pockets and everything else when you do welding. And it was my understanding, somebody told me that they were butt welds in the bottom of the tanks. And I surmised that y'all have had some minor leaks before. Because if you detect something in this field, and I assume that y'all have before, then there must be minor leaks. And just based on what I've seen before in my life, I thought that the tank, would be made out of steel, and they could have small minor fractions somewhere. And all the material I ever messed with, I know epoxy pretty much stops moisture and oxygen from getting to anything. And I thought that using the epoxy would seal the tanks, and also if there were minor leaks in the tanks, seal it all up. The hazards, and knowing that there is some radioactive stuff left in the bottom of the tank, I don't know, what the impact would be on this. But I was just thinking, and long term, and I know the grout you usually, it's basic cement, and it's got water in it. And steel, unless it's protected, and if you've got oxygen and you got water, steel's going to rust. And, is it good for 1,000 years, what y'all doing? I don't know. But I started thinking if it was coated with something, maybe that might make the seal if there were any minor leaks in there. And also, would it be feasible? Maybe it would be good to seal the tanks up for the next 1,000 years. That was just my assumption for putting it in there.
Okay, yeah, and again, some of that, and that's probably, again, we certainly can get to that report that I mentioned about the degradation of the steel. What we've seen is that liquid, when you mix the pH of that liquid, that water that you put in initially, once it contacts with these Portland cement, the pH goes up significantly, and so that's what helps with retarding corrosion on the steel. But again, we can certainly provide you all those documents for your information. To get to your one question about the bottom plates of the tank, you're correct. They were butt welded plates. They were actually suspended off the floor, and they welded from both sides, from both the top and the underside of those of the floors, and then the floor was literally lowered back down onto the base mat. Underneath that base mat, there are drainage pads, such that if we had any leakage on the bottom surfaces of the tank, they would leak to the annular areas, and we'd be able to see them. To my knowledge, we've never seen a leak that we believe was from the bottom part of the tank that leaked out underneath that drainage layer. We have, of course, seen, and you've seen pictures before of leaks where we had some pin leaks in sidewalls of the older style tanks. That, again, none of it got out into the environment, was contained within the annular space. But I don't know of any on the bottoms of the tanks. You are correct. Other sites have used epoxy, and even not epoxy sprays, but epoxies where they literally poured them into the liquid that would harden on the bottom. That's been done in other applications, not waste tank applications, but basin applications. But again, we haven't seen anything like that in our tanks.
So you're going to guarantee it for 1,000 years, then?
Well, I mean, that we have no evidence that we've had the degradation to date with the high pH conditions. And we don't expect that when we put the grout in and we continue to have those high pH conditions, that we should have any change in those conditions over a long period of time.
Okay.
Yeah.
And again, we do have tanks that have had leaks in the sidewall of the tanks at some of those stress-induced corrosion spots. And those, in our performance assessment, we model those as having a hole in the tank, just again matching existing conditions. But those are in the sidewalls on specific tanks, that we inspect those annuli and look for any of those defects. And the performance assessment does model that it has a through wall issue in the sidewall of the tank. That is part of the PA.
And what's been the cause of the sidewall leakage?
We think that was I'm not the expert on the corrosion part, the rest of the corrosions, but I think they were stress-induced corrosion cracks, is my understanding.
What, cracks in the steel?
I think it was stress
they-
corrosion.
One second, we have a comment from the room.
Yeah,
Okay.
please.
This is Chris Langton, and I just wanted to say that there's a difference between a closed tank and a tank with liquid waste in it. The closed tank has solid material in it. It is a mixture of cement and water and other reactive cementitious materials for a couple of hours. After that, it's a solid material. So the solid material is not going to leak out. Most of the soluble, the vast majority of the soluble contaminants have been removed in the tank cleaning process. It's the insoluble contaminants that are present as a thin coating or some particles on the sides and on the bottom of the tank, and they're not going to leak out. They're solid. So that's one difference between the concept that you're thinking of and the closed tank issue. The other thing is, you mentioned that when you do welding, there are pockets and there are defects in the welds. Well, you get the same thing when you put a coating on, an epoxy coating. The epoxies can't go on a damp surface to start with. If it goes over a crack that's got moisture in it, it'll probably form a pocket, and there'll be first debonding, then delamination, and it doesn't help. You haven't solved a problem. But the biggest thing is the closed tanks don't have any liquid in them. If there is, well, the PA modeling uses the mechanism of diffusion, where soluble contaminants move through a film of pore water. Another mechanism would be infiltrating water from the surface, somehow gets into the capped closed tank and travels 35 feet through the concrete and out the bottom. Well, that's a slow process. I mean, if it happens at all, and it depends on the integrity of the cap and the watershed capabilities. So for this case, I don't think a coating of epoxy or any kind of polymeric material would help, and it may make things worse. Because the coating interrupts the passivation that's obtained from the high pH and chemically reducing conditions that keep the metal intact. Does that help at all?
Well, it does and it doesn't, because here's the other thing. Looking at, we talk about the grout. It's just basically concrete, and concrete will let moisture and oxygen through it always. And you've got a ventilation system, and the humidity in the air always changes. I guarantee you can take that grout anytime, and there'd be a variation in the amount of moistures in the grout, or the amount of oxygen that's being transferred through the stuff.
Well, yes and no. The oxygen has to travel, it has to get through a watershed cap over the top. It has to dissolve in pore solution, and it's very slow moving as bicarbonate dissolved in water. This is not concrete sitting out on a sidewalk. This is concrete that's been backfilled and covered and capped
I
in a
understand.
steel tank.
I understand, but I'm looking far down the road. because, it's like, we're going to take this, we'll put the grout in there, seal it up, and it's good forever. And I'm just trying to think about forever. That's all.
Well, the performance modeling that's been done, it's really, it's very good. I would say we're leaders in the country on this, in the world maybe. But the mechanisms for corrodant transport, which would be oxygen, water, and CO2, are well understood and documented and incorporated in the modeling calculations. And what they show is that in 1,000 years, the closure is protective of the inadvertent intruder of the groundwater, and I don't know, whatever else that they model a couple of different scenarios. Now, that's not forever. 1,000 years is still historic times, and they're concrete materials that exist. The structures themselves aren't functioning as they were intended because of structural issues. I mean, there have been so many wars in the areas where these things happen or these things are built. But in this closure scenario where they're buried underground, and there is the assumption that DOE will retain the sites in perpetuity. So, that's the assumption.
Yeah, and I'd say just as Chris mentioned, is that the modeling doesn't assume that the intact properties at the time of pouring stay those properties forever. They immediately start to degrade. It's just how fast do they degrade? But in all cases, the modeling assumes that the grout and the steel and all the other structures, they do not maintain, they don't stay pristine. They degrade, they start to degrade immediately. It's just the rate of degradation that we look at.
Well, how thick is the steel in the base of these tanks?
Half-inch?
It varies by tank design. There's somewhere there, I think the thinnest one may be a 1/2 inch. Some of them are up to 3/4 to 1 inch.
That's correct.
And there's one other thing to say. As the steel corrodes, as the carbon steel corrodes, it turns into rust, which is iron hydroxide. And
Yep.
iron hydroxide is a very good sorbent for multivalent cations and some anions. So it forms an additional barrier as it corrodes. And the biggest thing that I'm seeing is that you're thinking the tank is full of contaminated material. That's not true. It's all been moved. Most of it's been removed, and it's just the tiny amount of residual that the regulators allow to remain in the tank because we can't polish the steel to be pristine clean.
I read somewhere it's plutonium generally on the sidewalls, someplace. And then the grout, last year when I heard about, the plants growing on top of the buildings, I looked up a lot on concrete, and they got the Parthenon and let's see, in Rome. And,
Mhm.
that concrete there still survived all these years.
Athens.
But, yeah, well, I said Athens, the Parthenon in Rome, isn't it? Not
No,
No,
the
no.
Parthenon, but the
No,
Parthenon.
it's in Greece.
Parthenon. And the roof on that, though, it's made out of it's concrete, but they used quicklime to make their concrete instead of flake lime.
Well, the hydration products of the ancient Roman concrete and the modern concrete are the same. Lime, slaked lime, they used to put lime in water, chunked up lime in water, mix the chunks and the water with volcanic ash, and they get a calcium silicate hydrate. Portland cement gives you exactly the same thing, except it's much better and much more efficient. So it's the same material, same phases.
No, it's not the same material. It's quick
It's not
lime.
the same material, it's the same phases that have persisted.
What was it, calcium hydroxide as opposed to, was it calcium oxide?
Well, calcium oxide, as soon as it gets wet, it's called slake lime because it gives off a lot of heat. So it's like slaking your thirst.
Yeah,
It
what
gives
they
off a
use.
lot of heat. They have to release the heat, then they mix that powdered up and chunked up lime with water and mix it with volcanic ash. The volcanic ash it's not complicated. It's just they dig dirt from nearby and mix it in because the dirt is volcanic ash. So the Portland cement concrete of today is a much more refined product and much more predictable. So,
Well,
and they reinforced their concrete with straw and or fibers, rope fibers kind of thing. We use steel. So our tanks are made of reinforced Portland cement concrete.
well, Portland cement concrete is not the same as what the Romans used.
No, they use dry packed lime pozzolanic concrete.
Because
But the hydration products are the same. The things that cemented together, the phases that cemented, the ancient and the modern together are pretty much the same.
well, except the Roman one lasted 2,000 years.
Ours
what we
lasts a
have.
long time.
Well,
Oh, Pat, I think you've been muted.
There we go. Okay. And I guess I'll just touch on the second recommendation.
Uh-oh.
Kent, you're me. There you go.
Okay. I wasn't clicking anything. Okay, here we go.
I can say one other thing. Okay. The Hanford site is looking at refurbishing waste tanks because they don't want to build new waste tanks, although they have permission and funding to build, I think, 4 more, but they have a lot more, they need more capacity. So they're looking at refurbishing waste tanks that they've emptied. Now, these would be emptied and cleaned and dry. And they are looking at installing a false bottom of concrete coated with a layer of sealant or just the false bottom concrete of a special concrete. So, but that's to put new, very low contaminated wastewater in if they can't get additional tanks built. And it's to increase capacity. That's not our case with tank closure. We're emptying, filling, closing. So if you hear about that and run into it, I'm just giving you a heads up that it's a different case, a different intended objective. And they don't expect those tanks to last, if they can refurbish them, and they do pass a leak test after they do this. The tanks we're talking about are in a lot worse shape than ours. If they can get over all the hurdles, regulatory hurdles, they don't expect them to last more than 20 years after they've refurbished them because they're going to be in use. And after that, they would close them like we're closing them. Well, that's the plan anyway.
So now with all of this information that you all have been given, I would like to bring our attention back to the recommendation. So for the board members, let's take a look at the top. Let's review the information that, the background that Pat has provided. And if you'd all like to open that up for discussion, if you'd like to make some edits, now is the time to do so. If you need a minute to take a look, that's perfectly fine.
Can we add some clarification in the background? The statement that the steel plates are butt welded is not universally true. Most of the welds are full penetration welds. Not, I think Kent said the bottom is butt welded, but most of them are full penetration weld. It says that they were not X-rayed. I think the welds were all X-rayed. I don't have the facts in front of me, but I believe that they were X-rayed. And Ken or Aaron, Staub, you can add clarity there or correction.
I believe almost all the welds were X-rayed.
So they weren't butt welded. So, okay, we're gonna go ahead and make it.
No, I think Kent said the bottom was butt welded on some of the older style tanks. Most of the welds on the tanks are full penetration welds, which that's the best weld you can do. Yeah. And
so full penetration.
Yeah. And so the
Full penetration.
It's full penetration.
Right here.
Yeah, I would really encourage y'all to read the PA documents that were referenced, because it will describe the design of that relative to maintaining the integrity before you would. This is what I would recommend before you put out any kind of a recommendation. Some more in-depth understanding of what is engineered into those waste forms is a very important piece of this.
Can you send us the links for that? For those documents?
We can get them that, right?
Yeah, the H tank farm PA, the newest revision is not yet out in the public realm, but all of this information about the design of the tanks, et cetera, is in the previous versions, and they are all out and available. So we can get you that.
Kent, that would be most helpful. You can actually email them to myself, and I'm Juanita Campbell or James Tainer, and we will make sure that they get to the board members for review. And having you both here to help us gain a better understanding of how the tanks are actually constructed is a crucial part of this sort of recommendation. For the board members, I ask, how would you like to move forward? Would we like to continue editing? Would you like that information first? What would you like to do?
I think
I have my
Pat's trying
hand
to
up.
speak.
I have my hand up.
Okay. Who's speaking?
Okay.
Kim, go ahead.
Good afternoon, everyone. I just have a question. I've heard some comments from our subject matter experts, and before we continue editing or doing anything else, I just have a question. Is that process that's in that recommendation, is that even the type of process you all would consider using before we take the time to go through this recommendation?
No, it's not practical either to apply it, or its effectiveness, or its design life within that field would not last as long as what we credit in the PA. And Kent or Aaron, feel free to correct me or add comments.
Agree.
I agree with that, because to apply a coating, epoxy or any other kind of coating, you need to do a lot of surface preparation. You can't apply it to a dirty surface because you won't get bonding. So it's not practical at all. And if there's moisture in the tank, it's not practical for another reason. Then all this cleaning and drying and removal of cleaned up of material knocked off the wall has to be done remotely in a tank that's with limited access. It's not practical.
The radiation,
opinion.
the radiation fields drive home her point, even with the residuals. These are not normally, when you do epoxies, it's very, very labor intensive, hands-on, everything she was describing. And in this environment, you can't get in there to do all that, and it wouldn't be beneficial if you could. So
Thank you.
So then, how about we're looking at number 2, install radiation monitoring within the liquid tank farms. to a level that individual tank leaks can be detected by triangulation.
Yeah, you were going to speak to that.
Yeah, I can. So number one, I'm not sure how familiar you are with, we do currently have a series of groundwater wells that surround both of the tank farms. And so we have a requirement to provide that to the state, and it goes to the NRC as well, where we monitor the groundwater in all of those wells, again, around the tank farms today, and that will continue into the future. I'll just make two comments about radiation monitoring. I'd say number one, the radioactive material may not be the first indication that we've had. If we did have a leak, that it would probably be the nitrates, things that travel extremely fast with the water. Those would be our first indication. So it wouldn't be the radiation anyway. It would probably be a chemical condition that would be the first indicator. And I'd say number two, if we were to install radiation monitors, the kind of radiation levels that we'd be looking for in the water itself, not, again, this is different than in the tanks, but in the water itself, are picocurie per milliliter kind of levels that, quite frankly, sometimes even when we do have things like that at those kind of levels in tanks, etc., it's you need to have a laboratory analysis to do that. So we couldn't install additional wells, but I think we have a very robust monitoring system, well system already around the tank farms. That, again, we're looking at that today. That's not, and again, that will continue after closure. But we're looking at, we use that system today to monitor the in-service performance, just as a backup to make sure we know what's going on there.
Kent, that's all tied to our permit, right?
Absolutely. It's all tied to the state permits. We have to provide the groundwatering reports once every year on those systems.
Thank you once again for that information.
Sure.
So I now ask I'm sorry. Oh, so now I ask our board members whether or not there will be a decision about taking this recommendation to the full board, or if you are satisfied with where we are now.
Well, I'd like to hear from Pat on that. Pat?
I think Pat has
Pat, are
disappeared.
Pat, are you muted or? Uh-oh, he looks frozen. Yeah, maybe the signal
Okay,
dropped.
there I am.
Okay.
Y'all hear me? No, I have a question. How many acres does the tank farm occupy? You hear me?
Yeah, we do.
Yeah.
I think.
Sorry, I just pulled up
Ken, are you near pulling something up?
Yeah, I am. I just pulled up the PA online here. So, and again, we'll be able to send you this link. It's out on the NRC website, publicly accessible. So hold on a second. I'm pulling up the H tank farm PA. I can give you, instead of pulling something off the cuff, I want to make sure I give you a good. So H tank farm is 395 acres. And that's the bigger tank farm. I don't have the F tank farm one pulled up right now, but
Okay.
H tank farm's 395 acres.
Okay. And how many monitors do we have in the ground?
Let's see here if I can pull that up or not. Sorry, we just issued that report to the state not very long ago. Hold on. Okay.
While Kent is looking that up, F Tank Farm is 22 acres within F area, which is 364 acres.
I'm sorry.
Okay, that's quite all right. I would love to hear some comments from our board members while we're sitting here waiting as well about this, what you all would like to do about this recommendation.
Well, like I said a minute ago, I'd really like to hear whether Pat still wants to move forward with it.
Mhm.
Well, see, my other question is, we're talking 395 acres, correct? And how many monitors do we have for 395 acres?
It's only 22
It's,
acres.
it's only 20, how many acres?
22.
It's only 22
F-
acres, Pat.
No,
Okay.
F Tank Farm is smaller. F Tank Farm was much
Oh,
smaller.
it's tank farm, okay.
Oh, F10, okay.
So how many monitors do we have for whatever acreage we have?
I need to see if I can pull that one up.
Yeah, there's a couple ways we can do this. If you can't get it quickly, with the PA material that we send to let y'all review that, we can obviously send you the monitoring plan with all where the wells are and how many we have.
Yeah, and I did not find it I'm looking in my inbox, but it's not a small number. It's trying to remember. Again, I don't want to give you a number offhand, but it's probably 20 or more.
Okay, my position is it a sufficient number of monitoring for the tank farm?
And I think our answer would be that the state regulators of our permits would have blessed it and said it is, and it's technically defended. So
yes, and if the state sees anything that they have questions about, etc., we have in the last few years put in additional monitoring wells where they said, hey, maybe let's put one here to make sure that we're not missing anything and things like that. So they do actively watch those wells and watch those results. And we have in the recent past, we do put in additional wells as requested for those systems.
Pat,
Sorry,
let
I
me,
just can't find the numbers, but I can certainly get
Pat,
the.
let me
get the
correct Kent real quick. So Kent said that, Kent meant that H area is 395 acres. H Tank Farm is 45 acres. So H Tank Farm is 45 acres. F Tank Farm is 22 acres.
Let's see, my bottom line here, very simple, and I don't care what the state says. Y'all have all the smarts and everything else. I'm just asking questions. I'm asking you, do y'all have sufficient monitoring for these tank farms?
and
Yes.
yeah, and our answer would be yes.
Okay.
I would like to know.
45.
One other comment of the document that we probably can share. There is the site groundwater monitoring
Total.
program document,
H area
And
is
it-
395.
and it speaks to the whole site. And that's something else we could share with y'all as well, if that would be helpful.
That sounds great. So having that information, Pat, what is your determination? Actually, I'm asking all of our board members.
To me, if it's sufficient, and if we, now if y'all can identify a tank that is in trouble, that is leaking through the bottom, if y'all can identify that, then we ought to be in good shape.
Okay. It looks like, are there two hands up?
Yes.
Phyllis? Phyllis, go ahead.
I think that's right. I think if it looks like they've already done that kind of study to figure out what works best. and are satisfied, and the state is satisfied. So I think I'm satisfied.
Okay. Thank you for that, Marty.
I do have one additional question. Is
Sure.
there any monitoring for radioactivity in the gas phase?
In the,
So
I'm sorry, Marty, could you?
Phase, water vapor, hydrogen? Or is it
So-
all groundwater?
no, we also have, and probably the best thing Mike was referring to is the annual environmental report that talks about not just the groundwater data, but we do have airborne, we have airborne radioactivity and filter papers, et cetera, on tanks, facilities, general area, et cetera, that we look at for airborne as well. It's
I'm
not just
talking
water.
about vapors and not particles that would not be caught on a filter.
Yeah. No, we have certain carbon filters. We also have, anyway, I understand your
but-
question. And yes, we do have monitoring for lots of those things at the site.
Okay.
And probably, again, the annual environmental report is probably the best single document that talks about all of those different forms of monitoring that the site does.
All right, so is there a consensus that we are satisfied with things the way that they are?
I move that we table the recommendation.
Second.
All right. Is there going to be a vote? I mean, you
All in
really don't.
favor?
Folks, just chiming in, procedurally, we don't need a vote for a subcommittee meeting.
Yeah,
Right.
Yeah, it's just consensus based. So it seems like we have it unless anybody objects. We can set this one off to the side for now, maybe move over to the other one.
mhm.
Sound good?
Yes.
All
Sounds
right.
good.
Thank you, everyone. Sorry.
No, that's perfect. Thank you. All right, now we're looking at preventing the water damage and turf growth. Pat, would you like to give a brief explanation of this one?
Okay. This is just based on my own experience. But, I had a concrete block in the backyard. And about 40 years ago, I put some epoxy on it. And it's still on there. And this wasn't UV protected or anything, just out in the open. And it's still on there 40 years ago. And I asked for pictures of the top of the, what was it, the H facility, but they never could get the approval to let us look at them. But my assumption is that those buildings, they're all flat topped and they're made out of concrete. And concrete, very simply, over time, and I know it's Portland concrete, Portland cement we use today, it will absorb moisture, and also it has little cracks and divots in it. And moisture will collect when it rains. And if it's the winter time, it'll expand and the cracks get larger. And dirt flies all over the place, dust and seeds. And that's why you have vegetation on the top of them. And I thought for long-term storage, because this looks like what they're going to do, weld up the doors and shut these things down eventually, that on the tops of them, that all the little divots and everything, you'd have to check this all out, be all filled up with epoxy, and then the whole thing coated with epoxy. Because that would prevent, I think, further degradation of the cement up there, keep everything together. And I'm not an epoxy expert. I'm just going on what I've seen before. But epoxy, on concrete, people coat their floors in their garages, sometimes in houses when they build them. they do it to prevent moisture and everything coming up through them. And on cement, though, epoxy works great. And I thought this would prevent the growth of the stuff up there if you fill in all the divots and everything, and then coat the whole thing with epoxy. I think the life term of the cement would be a lot longer, because I've read some articles on just cement, and everybody says, well, it's 50 or 100 years. And I know even by spraying every year, you still have the dirt up there. And every year, the growth is going to come back. And as it gets in there, and then you could have all kind of stuff, and it's going to be dividing and cracking the concrete up there. It's a long-term solution is not to spray it every year. I thought this might be a good long-term solution. And epoxy may not be the thing. There might be some other chemical that you could spray the tops of these things to keep water away from the cement. That was my whole point on this. And it would have been nice if we could have seen the pictures of the top of these things, but I understand that it was never given the where we could see the videos of the tops of these things. So that's why I thought epoxy might be good. Anyway, I throw it up to the floor.
Thanks, Pat. Appreciate the description.
Okay.
What I can say is the same reason that you have plant growth on the concrete, you'll have the same condition on the epoxy. And that is that dirt, dust, bird droppings get on the surface and accumulate, and that's where the plants grow. So even if you put epoxy on, you have to put herbicide on, inspect every year, and use herbicides. Now, the roofs are not flat. Well, it's only certain rooms in the reactor building that's 105R and P that have been where there's contamination in the room underneath the roof. That's where the new roofs were put on. The rest of the building has roofs, and new roofs were not put on because there's no contamination there underneath the roof. The reactor vessel has a 7-foot thick, 3-layer of rebar cap on it. So there's a difference between caps and roofs. The roofs are just over rooms. The caps are over contaminated areas. The disassembly basin is a very large area, 100 feet by 50 feet or 150 feet by 50 feet, and it's got a cap on it, a 3-foot thick cap. So there's no way to keep, putting epoxy on would have the same maintenance issue as no epoxy. The concrete that was used for the new caps that are sloped, and in addition to being sloped, there are holes, there are slots cut out where the roof meets the wall so the water can drain out. And you can see that it's clear when you look at it that that's what you're looking at. So the concrete that was used for the roof slabs and for the caps is a special concrete. Well, it's the Site 4000 PSI concrete that's been modified with shrinkage compensating admixture so that the pores could be larger in cross section, in floor plan, in plan view, and thicker. It's got integral water proofer in it, which reacts over time to seal small cracks up to 50 micrometers in width. It can't see this material doesn't hydrate to seal large cracks like an inch or half inch or quarter of an inch even. But for fine cracks, it seals cracks. It grows in the particles that form this integral waterproofing admixture, hydrate and fill cracks. It has one more thing. Oh, it's got the rebar. Let me just check my notes and see what it does have. Crystalline waterproof. Oh, and it's got air entrainment for freeze thaw. So it's a special concrete. It does need to be maintained. But so would any other material put on top of that for the same reason that the concrete needs to be maintained. So that's it.
Thank you. And I do, just to tack on, oh, did we lose Pat again?
No, I'm here. I'm here.
Oh, okay. Just so you know, we are working on getting some footage to show you. I'm not exactly sure at the moment when, but we are working on it.
Okay, let me say this. First of all, we have standing water on top of these buildings, or you wouldn't
Not
have
now.
plants up. No, not
There
now,
isn't.
because the herbicide, right?
No, because new roofs were put on critical parts of the building that are sloped, that drain to the exterior walls. Now,
So
there
they
are parts of the building, there are rooms, there are roofs that are the original old roofs that have been coated with bitumen, mastic. They don't look, it doesn't look good because it's aged and it's curled up and cracked and it's peeling off. But those roofs are over sections of the building that don't have any contamination. So it's not an issue about those roofs failing or the walls for that portion of the building failing. The only
Okay,
part of the, yeah, go ahead.
I was just gonna say, so the place where the reactor is, that roof
Mhm.
has no growth on it at all, and never did, right?
Well, okay, where the reactor is, there's a 7-foot thick, 3 layers of rebar inside the building, just over the reactor. The top of the reactor is at ground level inside the building. And on top of that reactor is a cap, and the cap is very thick. It's very thick. It was designed to be very strong and thick because if the roof above it collapses and falls onto the place where the reactor is, falls on top of the reactor, they didn't want that cap to be in jeopardy, to crack. So the roof on top of the building is not the cap on top of the reactor inside the building. It's a different roof. It's a roof, not a cap.
I understand.
Sorry.
But my question is,
I gotta turn this on.
my question is,
Maybe somebody didn't like what I said. I don't know.
the roof over the reactor does have plants growing on it, correct?
Until the roof over the entire reactor building, 105 building, and over the disassembly basin cap can have plants growing on it, can have algae growing on it. Yes, and that's why the herbicide's put on.
But see, if you filled in all the divots and everything and put epoxy on it, the percentage of growth would go down completely, just about to nothing.
Okay, the divots are filled in with concrete. The concrete is engineered slope to the exterior wall so the water drains off. So there are no divots in the critical part of the roof. The non-critical parts of the building that have roofs, those roofs don't look so good. But I mean, they don't look that bad, but they're still there. but everything is sprayed with herbicide. And you would have the same need to spray with herbicide no matter what was on the surface. Just because it's exposed to the air and dust, pollen, leaves, birds, dead animals end up on the roof,
But
on
not
the
if,
exterior of the building.
not if you had no moisture up there. You have to have moisture.
Well, it rains. I mean,
Then it collects, then the water collects.
no, it doesn't. So the dust is damp and grows algae. I mean, all this pollen and dust. I mean, my house, everything grows algae here. And the algae builds up if you don't clean it up. And it doesn't take long for that to form a base that holds moisture and plants can grow on it.
And I think what, if I may, I think what Pat is getting at is there a way that no moisture can be there? He's
You can
thinking
put
that,
a bubble over the roof.
because
You'd
the
have to
more,
epoxy that bubble on the roof.
right, because, he's saying that if you epoxy it, then the water
Right.
would just run, instead of collecting, I think he's
It-
thinking it wouldn't seep in.
On the roof that's covering rooms with contamination,
Mhm.
the water runs, the roofs are sloped to the
Mhm.
exterior walls.
Mhm.
They're not just cut in the exterior walls, so the water runs
Right.
off. And that would be the same thing that would be done for epoxy.
And we
It-
do,
And it's the same thing happens on the concrete roofs that would happen on the epoxy roofs. Dust, debris, things collect,
sure.
or it's coated. I mean, if you look at the new roofs when they were new and the roofs now are, there's no vegetation, but they're kind of gray and black. The roofs when they were just put in are white. So there's biofilm growing on the roof. It would grow on the epoxy too, unless you put mercury or chromate or something on it.
Something
some
you wouldn't want out there.
toxic material in it.
Sure. And you do have this presentation, which I know that you presented last year during a subcommittee meeting. And I will go back and look in my email and I will resend that out so that they can review that information.
Okay.
Because this is really good information, but you also included pictures of what you're talking about.
Right,
Those grooves where the water drains off the side and the discoloration on the side of the building, which I saw.
right.
I remember that. So you also have some information that they can then review on their own time.
And I guess the thing to say is the mold and mildew and algae, it can grow on the side of the building too. You have to, I mean, if you wanted to do something more to the structures above contaminated areas, you'd have to do the sides of the top hat of
Right.
the actuator tower of places. It's a different job than just covering the roofs.
Right.
Okay, two things. If the bituminous, I know that stuff will break down its organic material. And it may be adding to the vegetation. Maybe the roofs need to be covered with that. And the other thing is, though, if you're sloped and it's really sloped well, moisture will run off and there won't be anything left to do the propagation of the plants. And I'm not really worried about that. What I'm worried about is long term, about the top of these structures cracking and going to waste. And if there's a way to prevent this from happening, I think it should be done, because looking down the road, a few hundred years, and the roof collapse, I understand that the reactor is completely, safe. But I think we ought to have all the protection we can on the reactor.
I've been
Well,
trying to get into this. Hold up. I've been trying to get into this conversation for a while, so let me just say something on this issue. I would suggest that we stop arguing about it. And this recommendation, I think we should forward to the full board meeting I'm not quarreling with our experts' presence, but I think the long-term issue of the roofs and the problems that could be caused by vegetation growth, I think those are serious matters, and I think it'd be a good thing for the full board to discuss.
I second that.
So with you being in subcommittee, you don't actually have to vote on that, as James stated earlier. But if I could get, would you like to make a, no? Okay.
I'm okay now.
Board members, what would you like to do?
Let's send it to the full board.
Full board.
Full board, I hear Marty and Pat and Hubert suggested it. Phyllis?
I'm okay with that. Yes.
Okay, all righty. Sounds good. Any other comments or questions regarding this recommendation? Nope, okay. Hearing none, we'll move on to public comment, which I think that all of us here are employees. So I once again will ask any more comments or questions or discussions or topics, anything else?
I do have questions.
Yeah, what you got, Kim?
Where are we on the appointment of our board members?
Good question.
On the appointment of, so the last bit of information, the last update that we had was we sent the membership package to EM. They reviewed that information and then they forwarded it to the next level or the next group to review. And so that's where we are right now. Once that package has been reviewed by that sort of second level of reviews, we will get an update from our EM representatives.
So how many active board members do we have right now?
Currently, you have 10 active board members.
Okay.
With the potential of 9, I believe.
What is that?
And that,
Oh, you mean 9 that are pending?
yes.
Okay.
Any other questions? All righty then, Ms. Phyllis.
Okay, thank you. I think this clarified a number of things and gave us something to think about when we get the materials that we've been promised before the next meeting, which will be where? Do we know yet?
So the full board meeting in May is going to be at the DOE Meeting Center where we met for March.
Okay. All right.
And that's going to be on May 20th. So you will be receiving the invitation for attendance via email, the Google form from Chris. So please check your emails and respond accordingly so that we can get reservations made for those of you traveling from out of town.
And that's a one-day again?
Yes, it will be a one-day meeting. We are actually going for all of our full board meetings. We're going to go to one day.
Good.
And they will be in person. And then for all of the subcommittee meetings, they will be through virtually. We will meet virtually. So.
And all online? I mean, no, all on Tuesday?
Yes.
Okay.
Okay.
All right.
Juanita?
Yes.
I'd like at the next meeting, whenever you want to fit me in, but I'd like to bring some stuff for show and tell about the things I've been talking about. Just so everybody can have a hands-on feel for it.
Okay, Pat, James and I will discuss that and see where we can fit you in on the agenda, okay?
All right, I'll appreciate it.
Sure thing.
Just do me a favor and don't bring a lawnmower blade next time, okay? I need you to find something else. I got too many questions about you bringing a weapon, Pat. You've got to bring something different.
We'll talk about it.
No, you can't bring a mower blade. You got to bring something else.
Well, this is made up and ready to go, so. And it's an old mower blade that's worn out.
I understand that, but please listen to me on this. I need you to do something else for that. You could keep your speech, you could do everything else, but if you bring a lawnmower blade in the room again, I might have to ask you to leave it. Leave with
All
it.
right. I
Okay.
hear you.
Thank you.
All right.
All righty. Well, thank you all for joining us today. Thank you to everyone that's in the room for your time. And I will get busy on getting the information emailed out to you for review. And then you will be receiving emails from us regarding the full board meeting. So.
Oh, one
Anything
last
else?
question. Did everyone
Yeah.
get the work plan? Was I the only one who somehow didn't see it? No.
Actually,
I got it.
oh, well, that's interesting. Well, I will send it out. I will send it out again. But this time you're actually going to receive the work plan.
Okay.
All right.
Super. All right. If there's nothing else to be discussed, I'll see you May 20th. Thank you very much. Meeting adjourned.
Thank you.
Y'all want to stop recording?
Recording.
Yeah, tell them I left. I left the meeting, so the recording is in there.
There. I found it.